So for the first part, which of these guitar strings will have the highest wave speed? How do you know? This group said linear density, the smallest linear density is going to have the highest wave speed. We learned that from our lab last class, correct? We had the plastic and the metal, and the plastic moved faster. Was there any group? I think all groups got that conclusion, right? Were there any groups that got something different? So for sure, the smallest, I think the smallest string is actually here. The smallest string is going to have the fastest wave speed. And then there is one thing that we can't tell from this image, but is there anything else that we would need to know to figure out if it has a higher wave speed? I'll have my musician here, Justin. The tension. We can't tell how high the tension is, but we learned that the higher the tension, the faster the wave speed goes. So high tension is faster as well. All right. Any others that need to be added to this? Okay, let's go on to this part. This part we haven't actually talked about besides the three things from our Slinky Lab. We haven't talked about how amplitude and wavelength affect the wave speed. This group came up with C, D, B, and A, and they actually have it pretty close. The only things I want to add in here is some equality values. So C and D are equal. B and A are equal. Now I want to point something out. I'm going to give you this equation, although next class we're going to prove the equation is true. It's the fact that the wave speed, we use V for velocity, is equal to frequency times lambda. Lambda is your wavelength, and F is frequency, V is wave speed. Do you see anything about amplitude here? No, amplitude does not affect the speed of a wave. One thing that does affect the speed of a wave is your wavelength. And so if you have a higher wavelength, assuming the frequency was the same, you're going to have a higher velocity. So if you look at the wavelength for C and D, it's much longer. They're the same. B and A are smaller, and they're equal to each other. So your answer is C equals D is going to be faster than B equals A. And if you think about the fact that they're bigger waves, the front of that wave is going to reach the end a lot faster just because the wave itself is much longer. Any questions on this? So I want to add something here. Amplitude does not affect speed.